Hey guys, welcome back. So in the last video, we saw how to find time complexity of a iterative algorithm. Hope the idea was clear. Now in this video, let's see how we can find time complexity of a recursive algorithm. So here we have an array which is an unsorted one, and our task is to find the highest number in this array. So here is a recursive algorithm to do this. So the name of the method is find biggest number. It takes the array from which we need to find out the highest number, and it takes the size of the array. Then it initializes a variable which is of static nature with integer dot minimum value. If n equals to -1, that is, if the size of the array is -1, in that case return the value in the highest variable. Else check if the current cell's value is more than already known highest value. In that case, update the highest value. And then do a recursive call on the same array, but the size of the array is now reduced by 1. Now let's quickly do a dry run of this method. So initially the value of n over here is the size of this array. That means n is right now pointing to the last cell in this array. Now we are initializing highest with integer.minimum. If n equals to -1, no, right now n is not equals to -1, it goes to else. If an greater than highest, yes, an, which is this cell over here, currently is more than highest. Now what is there in highest right now? It is integer dot minimum. So 10 of course is more than integer dot minimum. So we update highest. So right now the value of highest is equal to 10. It is no more integer dot minimum. Then the next step is we do a recursive call on the same array with n-1. Now when we do n-1, so it starts pointing to this cell over here. So again it does a check if n equals to -1, no. Else if the current cell's value is greater than highest, no, it is 1, so it is not more than 10, fine. Then return a recursive call a n-1. So again now n starts pointing to this cell over here. So if n equals to -1, no, return highest, it will not be executed. Else if a of n, that is current cell's value greater than highest, yes, current cell's value is 19 and highest's value is 10. So we update it and make it 19 and then do a recursive call a n-1. So it now starts pointing to this cell. So this is how the recursive call will keep on continuing till it reaches the base condition. Now what is the base condition? It is this statement over here. That is, when n equals to -1, it simply returns the highest variable. It does not do any more recurrence. Fine. So I hope you have understood how does this algorithm works. Now let's see how we can find out the time complexity of this algorithm. So here we have the same algorithm from the previous slide. Now let's see each and every statement, how much time it takes. So updating a variable is a constant time operation. Doing some comparison is again a constant time operation. Returning a variable is a constant time operation. Else is a constant time operation. Comparison of value, constant time operation. Updating some variables is again constant time operation. So till now all of them are order of 1 and simple. So we are good. Now the problem arises when we encounter this statement over here. So what we do in this case? So in case of a recursion, whenever we find a recursive function, we have some standard steps to do. So what we do here is we assume that this algorithm is gonna take t of n time. Now if we can assume that it's gonna take t of n time, then if we replace the value of n with n minus 1, then we get another function which takes t of n minus 1 time. So what we have done? We have simply replaced this n with n minus 1. So we arrived at t of n minus 1. So now if we add all of these operations, we get order of 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus t of n minus 1. So we got our first equation, that is t of n is equal to order of 1 plus t of n minus 1. Now when we have added all of this order of 1, we are replacing with only single order 1 because they are all constant time operations. Now the next step is we need to find out the base condition. Now what do we mean when we say base condition? Base condition means a value of n for which there is no more recurrence call happen. So in what value of n this recurrence will never be executed? It will be when n equals to minus 1. In that case we simply return highest. We never come till this recurrence. So can we say that t of minus 1 will be order of 1? Because if n is minus 1, only these two statements will be executed and nothing else. So we have put here as t of minus 1 is equal to order of 1. So once we have find out the base condition, the next step is we need to find few more equations which are derived from equation 1. So the next equation is equation 2, which is basically derived from equation 1. So all that we have done is we have substituted value of n with n minus 1 and found this equation 2. Similarly, we have found equation 3 by substituting value of n minus 1 with n minus 2. So this gives us equation 3. Now we will use this equation 1, 2, 3 and the base condition to find out the value of t of n. So how do we do that? Let's see. So here we have copied the same equation 1 to 3 and the base condition. Now let's see what to do next. So the next step is we are putting t of n is equal to 1 plus t of n. Basically we are copying equation number 1 over here. Next we are trying to solve this t of n minus 1. How do we do that? We simply replace the value of t of n minus 1 from equation number 2. So we have done that. Now if we do some arithmetics, it becomes 2 plus t n minus 2. Now again we have a problem. So we have t n minus 2. So we replace this value of t n minus 2 with this value over here from equation number 3. So it becomes 1 plus t n minus 2 minus 1, which is basically coming from equation 3. Now let's do some more arithmetic and we land in 3 plus t n minus 3. So again we have a problem. The problem is we are not able to get rid of this function which is t. So now we see a pattern over here, that is in every iteration this value over here increases by 1 and this value over here gets decreased by 1. So can we say that this is nothing but k plus t n minus k, and the value of k starts from 1 till n. Fine. So now most of our work is already done. So now all that we have to do is we have to somehow eliminate this t function over here. If we can do that, we are all good. So how to do that? So idea is simple. We already know that t of minus 1 is equal to order 1, which is our base condition. So now can we do something here to make it equivalent to t of minus 1? Yes, we can do. So if we replace the value of k with n plus 1, then that gives us this as t of minus 1. So here we have replaced the value of k with n plus 1. So this gives us t of n minus n plus 1, which results into n plus 1 plus t of minus 1. Now if we solve this, t of minus 1, we get the value order 1. So we replace this with order of 1. So this becomes n plus 1 plus 1, which is nothing but order of n, because 1 over here are constants and we can ignore them. So our total complexity becomes order of n. Fine. So I hope you have understood how to find time complexity of a recursive algorithm. Now since this concept is little bit complex, let's take one more example of a recursive algorithm and try to find its time complexity. So let's do that in the next video. Thanks for your time. See you in the next video.